Have you ever pondered about the universe's greatest mystery, dark matter? Now don't let the term dark matter confuse you. Despite its sinister-sounding name, it's not the villain of some cosmic comic book saga. Dark matter is an enigmatic substance that, as far as we know, makes up about 85% of the universe's mass. Now, that's a lot of heft for something we can't see, touch, or interact with in any of our usual ways. It's like the universe is playing a colossal game of hide-and-seek, and dark matter is the reigning champion. But how did we stumble upon this cosmic mystery? Well, it all started when we noticed something peculiar about the way galaxies spin. You see, galaxies are like cosmic merry-go-rounds, spinning in the vastness of space. But unlike your typical merry-go-round, the stars on the outskirts of a galaxy should move slower than those near the center due to the pull of gravity. However, when scientists observed these celestial spinners, they found that stars on the outskirts were moving just as fast as those at the center. This suggested there was more mass in the galaxy than what we could see. Something was adding to the gravitational pull, and thus the concept of dark matter was born. But here's the kicker. Despite its name, dark matter is completely invisible. It doesn't interact with light or any other form of electromagnetic radiation, so we can't see it, photograph it, or detect it with any of our current tools. It's like trying to find a ghost in a vast, cosmic mansion. So, if it's invisible, how do we know it's there? Stick around, and we'll dive deeper into this cosmic conundrum. We'll explore the clever ways scientists are trying to uncover the truth about dark matter. So hold on to your hats, folks. It's going to be a journey filled with cosmic puzzles, scientific intrigue, and a dash of astronomical awe. So, we know dark matter exists, but we can't see it. Sounds like a cosmic ghost story, doesn't it? But this is no tale spun around a campfire. This is science, and it gets intriguing. Dark matter, as the name suggests, is dark. It doesn't interact with light or any other form of electromagnetic radiation, so it's invisible to our eyes and our telescopes. You might wonder, how do we even know it exists if we can't see it? Well, remember that one time when you tried to spot a black cat in a dark room? You probably couldn't see it, but you knew it was there when you tripped over it. It's kind of the same with dark matter. We can't see it directly, but we see its effects on things that we can see. One of these effects is something called gravitational lensing. Picture this. You're looking at a star, but there's a massive clump of dark matter between you and that star. Now, according to Einstein's theory of general relativity, mass bends space-time. So the light from that star will get bent around the dark matter, creating a cosmic mirage. The star might appear distorted or even in multiple places at once. This is gravitational lensing, a key tool that helps scientists study dark matter. Now, if all this talk of invisible matter and cosmic mirages sounds a bit mysterious, let me lighten the mood with a little joke. Dark matter is a bit like the silent partner in a business. You might not see them, but they're pulling all the strings behind the scenes. So, we've got this cosmic puppet master, dark matter, influencing the universe in ways we can't directly observe. But through the effects it has on the visible universe, we can detect its presence and start to understand its nature. Now that we know how we detect dark matter, let's explore what it could be made of. Dark matter is like the universe's best-kept secret recipe. We know it's there, but what's it made of? Imagine you're at a cosmic potluck and the universe brings its signature dish, dark matter, but it's not sharing the ingredients. Two main theories have risen to the challenge of deciphering this recipe: wimps and machos. And no, we're not talking about a wrestling match between tiny particles and macho men. These are serious scientific hypotheses. Wimps, or weakly interacting massive particles, sound a bit like the shy kids at a school dance. They have mass, they're definitely there, but they're not interacting much with the other particles. The idea is that these elusive particles rarely interact with normal matter, making them incredibly difficult to detect. Despite the challenges, scientists all over the globe are experimenting with ultra-sensitive detectors deep underground, hoping to catch a wimp in the act. On the other end of the spectrum, we've got Macho's massive astrophysical compact halo objects. These aren't your average gym rats. Machos are large, dense objects that don't emit much light, like black holes or neutron stars. They're lurking in the outskirts of galaxies, in the halos, hence the name. Although they're difficult to spot directly, their hefty mass can bend and magnify the light from distant stars, an effect known as gravitational lensing. This cosmic trickery might just give away their hiding spots. Both of these theories offer fascinating insights into the possible nature of dark matter. But it's important to remember that these are just that, theories. They're still unproven and research is ongoing. Scientists are working tirelessly, sifting through data, conducting experiments, and crafting new theories. Our understanding of the universe is like a puzzle, with dark matter as one of the most perplexing pieces. Even though we may not have all the pieces yet, every discovery brings us one step closer to seeing the full picture. So, while we don't have all the answers yet, we're definitely on an exciting quest to find them. You might be wondering, why all this fuss about dark matter? Does it affect my daily life? Well, let's dive right into it. Simply put, understanding dark matter is crucial to our comprehension of the universe. It's like trying to solve a jigsaw puzzle with half the pieces missing. Sure, you might get a rough picture, but you'll be missing out on a lot of the details. And in science, it's the details that count. Now let's talk about galaxies. These enormous, glittering cosmic cities are where stars like our sun are born, live, and die. They're the stage for the cosmic drama that's been playing out for billions of years. But here's the thing. According to our current understanding of physics, galaxies shouldn't exist in the way they do without the presence of dark matter. Think about it. Galaxies are spinning so fast, the stars at their edges should be flung out into the void of space. But they aren't. Instead, they're held together in these beautiful spirals and elliptical shapes we observe. And what's keeping them together? You guessed it, dark matter. It's the invisible glue that holds galaxies together, allowing them to form and cluster the way they do. Now, here's a thought to tickle your funny bone. Without dark matter, we might not have a Milky Way to call home. Talk about a real estate problem. Imagine trying to explain that to your intergalactic landlord. Sorry, I can't pay rent this month because my galaxy doesn't exist. So, if you're still wondering whether dark matter matters, just remember, it's one of the key ingredients that makes our universe what it is. It's the unseen foundation upon which galaxies are built, the silent partner in cosmic evolution. And without it, we wouldn't be here to ponder its existence. So, as you can see, dark matter, while elusive, plays a crucial role in our universe. While we may not have all the answers about dark matter now, the future of research is bright. The quest to understand the universe's invisible mass is far from over. In fact, it's just getting started. Around the world, scientists are working tirelessly to detect dark matter particles. From deep underground laboratories to high-tech space observatories, the hunt is on. A prime example is the international collaboration on the Large Underground Xenon, or LUX experiment. Nestled a mile beneath the Black Hills of South Dakota, this detector is waiting patiently to spot a dark matter particle. The conditions are so quiet down there, it's like trying to hear a pin drop in the middle of a rock concert. Meanwhile, up in space, the Fermi Gamma Ray Space Telescope is scanning the cosmos for signs of dark matter. It's looking for an excess of gamma rays that could be the signature of dark matter particles annihilating each other. It's like a cosmic detective, piecing together clues from across the universe. But why are we so intent on finding this elusive substance? Well, it's simple. Scientific exploration is about more than just satisfying our curiosity. It's about pushing the boundaries of what we know and expanding our understanding of the universe. The pursuit of dark matter is a testament to our relentless human spirit. It's a journey that embraces the unknown, celebrates the questions, and savors the thrill of discovery. And who knows, maybe one day these efforts will lead us to a new understanding of the universe, one that includes an invisible mass that shapes galaxies and holds the cosmos together. So next time you look up at the night sky, remember, there's more to it than meets the eye. Who knows, maybe one day you'll be part of unraveling the universe's greatest mystery.